Lesson 11.1.3, Proportionalities. The term proportional appears often in ordinary language. Some of us might already have some notion of what that means. In everyday uses, someone might say, the time it takes you to complete the lesson is proportional to how challenging the lesson is. In other words, the time it takes to complete a lesson is comparable to, is about equivalent to, or corresponds to how difficult or complex the lesson is. For questions 1 through 6, please refer to the supplement at the end of the lesson. The goal of this activity is to take the idea of proportionality and through experimentation develop a mathematical definition. The supplement that they are referring to is at the end of the lesson. You should see in your workbook a couple of pages. One of them has polygons and a ruler, essentially a couple of shapes, and then on the other page, a ruler. Those are the things that we're going to be referring to. This might be before the take it home for the lesson in your workbook. So going back to question 1. A polygon is a shape with multiple sides. So that is what a polygon is, just a shape with multiple sides. The supplement for this lesson includes 2 strangely shaped polygons. The large polygon is labeled X, and the smaller polygon is labeled Y. Part A. From nothing more than a visual inspection and your own thoughts, do these polygons seem proportional to one another? When you're trying to think about this, maybe think about what they said about proportional. Do they seem comparable? Can you compare one to the other? Are they equivalent? Are they the same? Or do they correspond in some way? So if you're looking at those shapes, you can clearly see that one is bigger than the other. As they said, X is the larger polygon and Y is the smaller one. But do they seem to relate to each other? Do they seem similar somehow? So think about that. You can write whatever answer you want for part A. That's just an opinion question. But then part B. Is there some measurement you could make to check or verify your claim? What would that be? So if you're looking at those shapes, is there something that you could do that would involve some measurement? We do have a ruler available to us. Maybe something that we could do is measure and compare sides. If you're looking at those shapes, you might say something like, well, they both seem L-shaped, like a capital L. So if they're both L-shaped, maybe we could compare sides that are in the same place on the L shape and then measure them to see if they have some sort of relation. So that's one idea. So now next, after number 1, the supplement for this lesson also includes a 5-inch ruler. Each mark on the ruler is 1/10 of an inch. Remove that page and fold it along the numbered edge of the ruler, or if you have your own ruler, you can use that. With this, you can make measurements to the nearest 1/10 of an inch. Number 2, for convenience, the corresponding sides of polygon X and polygon Y have been labeled. To identify corresponding sides, imagine rotating the polygons so they are pointed or oriented in the same direction. For example, the 2 sides on top are corresponding, or the 2 sides on the bottom are corresponding. In the case of polygon X and polygon Y, side X with a subscript 1 on polygon X corresponds to side Y1 on polygon Y. Over on the right, it says the corresponding sides are the matching sides from the 2 shapes. So let's go take a look at those shapes and see those sides X1 and Y1. So you have polygon X is the larger shape, and X1 you can see is at the bottom of the shape. And here I'm just going to draw a red line that's on the side that is X1. And that is corresponding to the side y with a subscript 1 on polygon y. And I'm going to draw a red line there. You can imagine that these correspond to each other because imagine picking up polygon y and rotating it, maybe 180 degrees. Then you could lay it on top of polygon x and you'd see the sides that are corresponding to each other. This is the idea of just matching shapes to each other. All right, so now number 2, part A on the next page, I'm going to leave the pictures up. Number 2, part A says, use your paper ruler to find the longest side on polygon X. Which side is it and how long is it? Now, since I'm doing this on an iPad, I can't cut out the ruler and lay it against the side, but you can do this. You can take the ruler, you can pick it up because it's on a page, you can fold the ruler so that you just have the number side available to you, and then you could use that to measure the side that is labeled, the longest side on polygon X. Now we can see what the longest side is on polygon X. It's the longest side that is in that shape. That's the one that's labeled X5. Now the way that I'm going to have to do this is I have a piece of paper that I'm just lining up along the side X5. And I'm just making a mark of where X5 begins and where it ends. And I have it here as a little green line that I've drawn. And then I'm going to take that and I'm going to compare it with my ruler. And if you do this, you see that you get about 4 inches. It's not exact because these borders on the shape are a little bigger lines, so you got to think of maybe going from the edge all the way to the other edge, but it's about 4 inches for that side. So up on number 2, part A, I'm going to say that the longest side on polygon X is the side X with a subscript 5, and it is about 4 inches long. Then part B. Use your ruler to find the longest side on polygon Y. Okay, so if we go back to our shapes, the longest side on polygon Y, notice it has the same subscript. It would be the side Y with a subscript 5. So I'm going to again take my paper, I'm going to line it up on polygon Y on that longest side. I'm just going to make marks of where it begins and where it ends. You can of course use your ruler and just put it up against the shape. And when I compare the sides for where it begins and where it ends, I can see that side Y sub 5 on polygon Y is about 2 inches. So going back to number 2, part B, I'm going to say that the longest side on polygon Y is side Y with a subscript 5, and it is about 2 inches long. Now part C and D, they're asking for some other measurements. Use your ruler to measure side X1. That will be the answer for part C. And then also use your ruler to measure the corresponding side, Y1. So now we're just getting a couple of other details. So going back to our polygons, they want the measurements for side X1 and Y1. So I already have those highlighted with the red lines. So again, you can just use your paper ruler, put them up against those sides for Y1 and X1, and then just see what those measurements are. And what I get for X1 is about 1.2 inches, and for Y1 I get about 0.6 inches. So going back to question 2, parts C and D, the length of side X1 is 1.2 inches, and the length of side Y1 is 0.6 inches. So now part E. These two polygons are proportional to one another. Use the measurements you've made to explain what this means in this problem. How are the side measurements related? Your answer should include the ideas that we have talked about so far in the lesson. So, would you say that the corresponding sides are equal to each other? Like, is x5 equal to y5? No. x5 is 4 inches long and y5 is 2 inches long. How about side x1 and y1? Are they equal to each other? No. x1 is 1.2 inches long and y1 is 0.6 inches long. But do you start to see a relationship? Maybe think about, how are the numbers 4 and 2 related? And is there a similar relationship between the numbers 1.2 and 0.6? The corresponding sides on polygon X are, what's the relationship here? 2 times as long as the corresponding sides. On polygon Y. Because x5 is 4 inches, that's 2 times as big as y5, which is 2 inches. x1 is 1.2 inches, that's 2 times as long as y1, which is 0.6 inches. So part F. Suppose a side on polygon X has length x equal 1.8 inches long. How long do you expect the corresponding side on Y to be? Well, if the sides on X are 2 times as big as the sides on Y, then how would you get the corresponding side on Y? Well, you'd have to cut it in half. 1.8 divided by 2. And that gives you 0.9 inches, right? Because X equal 1.8 is definitely twice as big as Y equals 0.9. So now, number 3. Give a formula for computing a length of a side Y on polygon Y that corresponds to a side X on polygon X. We want a formula that will work for any value of X. So leave X as a variable. Think about what you have to do to length X to get length Y. And I would say just think about what we just did in part F. You took a length for X and you divided it by 2. And that gave you a corresponding value for Y. So I can take any value X and I can divide by 2. So you can say that Y is equal to X divided by 2. Or you could also say Y is equal to half the size of X, that's 1/2 times X. Those two things are exactly the same. Take a number and divide it by 2, it's exactly the same thing as cutting it in half, which means multiplying by 1/2. And what's a decimal that means the same thing as 1/2? Well, you could use your calculator if you don't know. 1 divided by 2 is 0.5. So all of those things are the same. So these answers that I've written here, these are all the same answer, just different forms. Okay, but they all give us a way of computing the length of side Y that corresponds to a side X. So now number 4. A table is given below with all the side lengths for polygon X. Part A, use your formula to compute the lengths of all sides on polygon Y. Enter the lengths in the table below. When finished, graph the equation you found above. So first, side X1, 1.2. We already said that side Y1 is 0.6. And can you take your calculator and take 1.2 and divide it by 2 and get 0.6? You sure can. Can you take 0.5 and multiply it by 1.2 and get 0.6? You sure can. You can experiment with that with side x2, which is also 1.2 inches. That would give you y2 is also 0.6 inches. Now x3. You're given that x is 2.8. Take 2.8 and divide it by 2. 2.8 divided by 2. I get 1.4. You could also take 0.5 and multiply it by 2.8. You still get 1.4. This is just confirming to you that dividing by 2 is the same thing as multiplying by a half, or 0.5. So now side x4 is 1.2. That's going to correspond with a side y4, which is 0.6. Side x5 we've already seen, 4.0 inches. Side y5 we said was 2.0 inches. And then finally side x6, which is 2.4 inches. I'm going to take 2.4 and divide it by 2, and I get 1.2 inches for side y6. Part B. Use the points you computed in your answer to question 4a to graph the equation from question 3. So here we have an x-axis, that's the horizontal axis, and a y-axis, that's the vertical axis. So now let's start with the first point. x1 was 1.2. If you look on your horizontal axis, 1.2 is almost halfway along the horizontal axis. I would start there, and then I need to go up to where y is equal to 0.6. That's also about halfway up. So I would get a point that corresponds to that. And notice that corresponds for x1, y1, x2, y2, and also x4, y4. So that one point that I just drew in green actually takes care of a few of the lengths that we had. So now I'm going to use a different color, and I'm going to graph something that works for side x3, which is 2.8, and side y3, which is 1.4. So I find 2.8 along the horizontal axis, which means I would start there, and then I have to go up as high as 1.4 on the y-axis. So that gives me this point almost at the upper right corner of the graph. And then for side x5, which is 4.0, well, we don't have anything for that here, but think about it this way. Do I already have 2 points? Can I graph the line? Sure can. But how about while we're at it, let's graph the last one that they gave us, x6, which is 2.4. And then I'm going to go up as high as y6, which is 1.2. And that gives me a point up here. And I'll connect those 3 points with a line. All right. So now number 5. What is the slope of this line? How would we find that? M is equal to y2 minus y1 divided by x2 minus x1. And you can use any of the points that they gave you in the table. But how about we just use the ones that are already labeled x2, y2, x1, y1. Now if I did this, notice that x1 and x2 are the same number. So what is x2 minus x1? If it's 1.2 minus 1.2, that's 0. And if I do the same thing with y2 and y1, that's 0. So that actually doesn't help me. This is where we want to use maybe the green point that I graphed and the red point that I graphed. Right? The x1, y1, and x2, y2, that came from the previous section, and it just stands for take 2 points that are on the line. So let's make sure that they're 2 different points. So I'm going to use, for my second point, the red one. I'm going to call that x2, y2. And then for the green one, I'm going to call that x1, y1. Right? I'm ignoring the subscripts now from the table that's above. I'm just saying those are my 2 points. Let's use those. So y2 for the red dot was 1.4. y1 for the green dot was 0.6. x2 for the red dot was 2.8. And then x1 for the green dot was 1.2. So this gives me 1.4 minus 0.6, which is 0.8, divided by 2.8 minus 1.2, which is 1.6. And when you divide those two, 0.8 divided by 1.6, that's 0.5. And then number 6, what is the y-intercept of this line? Well, let's go back to y equal mx plus b. Let's plug in the slope that we know, 0.5. And let's take one of the points that we had above. How about the green dot, where x was equal to 1.2 and y was equal to 0.6. And let's find out what b is. So this gives me 0.6 equals, when I multiply 0.5 times 1.2, I get 0.6. And now just look at this equation and think about it. 0.6 equals 0.6 plus some number b that you don't know. What's the only number that would work there? It would only be 0. But you could also verify that this is true by subtracting 0.6 from both sides so that you just get b all by itself. And you end up with b is equal to 0. So now we know what our y-intercept is. Y-intercept is b equal to 0. So now we know the slope of the line and we know the y-intercept. And now let's summarize everything that we just saw on this page. You need to know for this section, 2 variables are proportional if they are related to each other by an equation with the form y equal mx. Notice that there's no b here because b is equal to 0. So you don't need to write it if you're adding 0. This equation is called a proportionality. The graph of a proportionality is a line whose y-intercept is 0. We call the slope of the line m, which is also called the constant of proportionality. The slope of a line is a rate that can be positive or negative. We call a positive slope a rate of increase and a negative slope a rate of decrease. If x and y are proportional, we know that for any xy pair, the constant of proportionality is m equal to y divided by x. The units for the constant of proportionality, or slope, are units of y per unit of x. Proportionalities are linear functions. As x increases, y increases at a constant rate. Also, when 2 variables are proportional, the y is always the same multiple of x. Because of this, when one variable is 0, the other is also 0. So now let's just look at some examples. Number 7, Texas has a sales tax on most purchases. The following table shows, first, purchase amounts x before tax, and second, the amount of tax charged y for the purchases. So here's our table, purchase price x, and we've got numbers of $4, $90, $19.95, and $8. And then tax, y, we've got 32 cents for a purchase price of $4. We've got $7.20 for a purchase price of $90. We've got $1.60 for the tax on a purchase price of $19.95. And then finally a tax of 64 cents on a purchase price of $8. So part A, are x and y proportional? To help you answer this, think about this question. Is y always the same multiple of x? So let's see. We want to think for the tax of 32 cents, 0.32, is that a multiple of x, which is $4, And is that multiple the same for the next tax amount? Is $7.20 also the same M times its purchase price of $90? Well, to see if we can answer this, how about we use their idea of M should be equal to Y divided by X. So if I take the first equation that I wrote down, let's see if M equal to 0.32 divided by $4 becomes the same M for the second equation. So just taking what I have written here, 32 cents, so 0.32 divided by $4, that's 4.00, that gives you 0.08. Does that end up being the same for the second equation that I wrote down? Well, let's see. Here I would have M is equal to the Y value there, which is $7.20, divided by $90, 90.00. Take out your calculator, 7.20, divided by 90.00, and what do you get? 0.08. Now just see if that's true for the other ones. Can you take 1995, multiply it by 0.08, and do you get approximately the tax amount? You do. You get 1.596, which rounds to $1.60 because that's how we round dollar and cent amounts. And then how about the purchase price of $8? 8 times 0.08, that gives you 64 cents. So yes, and you can say that Y is equal to 0.08x. So now moving over to the next page, let's organize a little bit of what we just discovered. Part B, find the constant of proportionality for the relationship between x and y. Well, just like we did, m equal to y divided by x, we did that a couple of times. So for example, y equal to 0.32 divided by x equal to 4.00, that gave us 0.08. That's our constant of proportionality. Part C, the constant of proportionality is a rate. Explain what this constant means for the sales tax rate and how the tax increases. To think about this, let's go back to the previous page and just notice right below where they wrote m equal y divided by x, they said that the units for the constant of proportionality are the units of y per unit of x. So, back on part C, what you can think is for every 1 unit of x, which means for every $1 spent on a purchase, the tax amount increases by 8 cents, which is the same thing as saying $0.08. So that's taking the idea of units and then putting it in with this rate that we are getting for the constant of proportionality. Now, this is how tax works. We do that here in California. We have a different tax rate, but we have the same idea. Every dollar you spend, you have a certain amount of cents that you have to pay in sales tax. So now part D. What is the equation that relates x and y? We've already written this down. It was y equals 0.08x. Part E, what would the tax be on a $40 cowboy hat in Texas? So if you purchase something for $40, then the tax amount is what y is telling you. That would be 0.08 times $40 for the purchase, and that gives you a tax amount of $3.20. Part F. Imagine that you buy a pair of boots that are double the price of the hat. Does this double your tax? Well, let's see. What is double the price of the hat? If the hat was $40, double the price is $80. So in this case, y would be equal to 0.08 times $80. And when you multiply those two, what do you get? $6.40. Is that twice as much as $3.20? Yes. So number 8. We have discussed two models so far, the proportional polygons and the tax rate in Texas. Both of these models are based on data. Are these statistical models or mathematical functions? Explain your answer. So what we can think of with this is, let's refer back to the tax problem. Do you think if somebody else went and bought $40 worth of coffee for their office, would they get charged a different tax amount than the person who bought a $40 cowboy hat? No, the tax would be the same. So we only get one output for any given x value. So this is a mathematical function, and so is the polygon. So these are mathematical functions. And the reason why is because for any x value, there's only one y value. For any purchase amount, there is only one amount of tax that you'll be charged. Same thing goes with the polygons. If two sides on x were the same length, you only got one output that was the same for them also. We saw that in the table. If you go back to the table for the x's and y's, notice that when the side was 1.2 for x, you had 3 of those, you always had 0.6 as the output. So those are both mathematical functions. So now next steps. We have learned several facts about variables that are proportional. When one is 0, the other is also 0. As one variable changes, the other changes at a constant rate. One variable is always the same multiple of the other variable. The rate and the multiple are the same and are called the constant of proportionality. When one variable is 0, the other variable is also 0. In terms of a line, this indicates that the y-intercept is 0. And the rate and the multiple are the same and are called the constant of proportionality. In terms of line, this is the slope. So now a couple other examples. Number 9, Gary is buying books from an online bookstore. All of the books are $4 each. The shipping cost is $5, no matter how many books are ordered. Part A, write a formula for the total cost of the order, y, as a function of the number of books purchased, x. So here we can think about maybe what we saw in a previous example. We've got shipping cost, which is $5. And notice that shipping cost is no matter how many books are ordered. And then all of the books are $4 each. If you're trying to think of a formula, try to think of what we did in previous examples. Do some simple examples to help you come up with a formula. So for example, what is the total cost for one book? Meaning buying the book and shipping it. Well, if it's $4 for a book, then for one book, that's $4. Then add on the shipping cost, that's $5. So you would have $4 for the one book plus the $5, and that's $9. What would it be for 2 books? Total cost for 2 books. What would you have to do first? If you have 2 books and they're $4 each, then you have to multiply 4 times 2, and then you need to add shipping, $5. So that becomes 8 plus 5, which is 13. So now to get your formula, just think, what's the total cost for, how about what they say, X number of books. X books. You'd have to multiply the number of books by 4, so that's 4x. And then you'd have to add $5 for shipping, 4x plus 5, and that gives you the total cost, which they are saying is y. So this is just like what we saw, maybe if you think back to the example of going to the Fresh Plus or Costco to buy pounds of meat. Same idea. Part B, is this equation a statistical model or a mathematical function? This is also going to be a mathematical function. This is a line, as we've seen before. So it's going to be a mathematical function for similar reasons that we've seen. Also, if you buy 2 books today and 2 books tomorrow, it's going to be the same cost. Part C, is your linear equation a proportionality? So maybe to answer this, think back to the previous page. Here are some facts about proportionalities. Something that we can take a look at. As one variable changes, the other changes at a constant rate, and that rate is a multiple. What you might want to think of is the total cost for one book was $9, but if you get twice as many books, which means instead of 1 book you get 2 books, did the cost become $18? No, we don't have something like that. There's one reason. What's another reason? A very simple one. Is the y-intercept 0? No, it's not. The y-intercept is 5. So we can say the y-intercept is not 0. Part D, what is the cost of 10 books? Well, that would just be $4 per book times 10 books plus $5 for shipping. That gives you 40 plus 5, which is $45. Part E, if you double the number of books, does this double the cost? We already saw that was not true, so no. And what's a reason for that? Well, while the cost per book, when you multiply that by a double amount of books, that doubles, the shipping does not. So the shipping never changes. So that's really the reason. So the reason why this does not double the cost is because the shipping does not double. All right, question 10. In question 7F and 9E, we asked if the doubling of one variable must be accompanied by the doubling of the other variable. The doubling of one variable accompanied by the doubling of the other variable occurred in only one case. Did it occur in 9E? No. But if you go back to 7F, it did occur. So it happened in number 7. So write a rule for when doubling x always leads to a doubling of y. So what's the rule? When you have what we had in number 7, when you have a proportion, doubling x leads to doubling y. So now next steps on the next page. The following questions ask you to determine if 2 variables are proportional to another. Here is some of what you now know about proportionalities, summarizing some things that we've seen. When x is 0, y is also 0 in a proportionality. As one variable increases, the other changes at a constant rate in a proportionality. One variable is always the same multiple of the other variable. And as we just learned, when one variable doubles, the other doubles as well in a proportionality. Number 11. Alicia needs to buy rice from the bulk section of her grocery store. The bulk section allows you to buy rice from bins so that you can buy any amount you want. Alicia can buy 2 pounds of rice for $1.58. Answer the following questions to determine how much it will cost Alicia to buy 5 pounds of rice. So first, part A, let y equal the cost of x pounds of rice. If x is 0, is y also 0? Well, if you think about it, if she buys no rice, is she going to pay any money for that? No, she won't pay anything. So yes, 0 pounds of rice costs $0. Part B, does y double whenever x doubles? Yes. That's how buying things works. If you buy 2 pounds and it costs $1.58, buying 4 pounds would just be twice as much. Are x and y proportional? Yes. Part A and B are part of the reasons why it's a proportionality. So it matches what we wrote above. So it matches our descriptions. Part D, what is the constant of proportionality? Give units and interpret the rate by explaining what the rate does to the cost. Remember, the constant of proportionality is the same thing as slope, and we saw that for a proportionality, you could just take a y value and divide by an x value. So here, you could say that $1.58 is the y value. That is the output for buying 2 pounds of rice. And $1.58 divided by 2 is 79 cents. And how would you express this in your own life? You'd say it's 79 cents per pound. So what you should see from this is that intuitively, you already know how this works. Gas is a certain amount of dollars per gallon. Food items are a certain amount of dollars per pound. So we know if we pay a certain amount for 2 pounds, we can figure out how to get an amount for 5 pounds, like Alicia is wondering. And it's just using this idea of proportionalities. So continuing on to the next page, part E, what is the equation that relates x and y? Remember, this is just going to be y equal m times x, which means y is equal to our constant of proportionality here, 0.79 times x. So then you can use that to figure out how much it will cost Alicia to buy 5 pounds of rice. So the cost will be 0.79 times 5, and that gives you $3.95. Number 12. For a certain medicine, doctors prescribe a dosage of 400 milligrams, mg, per day for people who weigh 150 pounds. The relationship between a person's weight and the recommended dose is a proportionality. A person twice as heavy will need a dose twice as large. Answer the following questions to determine the appropriate dosage of this medicine for a 110-pound person. First, part A. Give the constant of proportionality. Also give the equation that relates a person's weight, x, to the recommended dose of the medicine, y. So remember, constant of proportionality, that's what m is. So here you would want to think the output would be how many milligrams does a person get? And the input depends on how much the person weighs. So 400 milligrams for a 150-pound person. When you divide that, you would get 2.667 milligrams per pound. What's the equation? It would be y equal to 2.667x. So then part B, what is the appropriate dosage of this medicine for a 110-pound person? That would be take 2.667 times 110. And when you do that, you would get 293.37 milligrams. Do you think this problem shows you the importance of proportionalities and using them correctly? It depends in this case because you've got medication you have to give somebody. You want to make sure that they get the correct amount. So you want to be doing this proportionality work correctly so that you do give the right amount to a certain person. If you think in terms of something not as serious like giving medication, just think in baking or cooking. Proportionalities are used all the time where you want to make sure that you have the right ingredients for the number of people that maybe you're making a meal for. So let's continue on to number 13. Janetta is 36 inches tall when she is 3 years old. Answer the following questions to determine how tall she will be when she is 30 years old. So let's see, part A. Think about Janetta's age and her height. Is it possible to use a proportionality to determine Janetta's height when she is 30 years old? Well, let's see. What if it was? If it was a proportion, then you would say that the constant of proportionality would be she's 36 inches tall when she's 3 years old, which means 12 inches per year. So you tell me how many years old she is, I can tell you how tall she is. That means that your equation would be y equals 12 times x. So now how tall would she be at 30 years old? So at 30, y is equal to 12 inches times 30 years. That's 360 inches. How tall is that? Well, there's 12 inches in a foot. So let's take 360 and divide by 12 inches, 30 feet tall. Do you think that's possible? That Janetta could be as tall as a 3-story building? So, no. Part B, if you answered yes to the above question, give the constant of proportionality and Janetta's height when she is 30 years old. So, this is not reasonable. So you can see that some things aren't proportionalities. We don't keep growing at the same rate that we did when we were children. And now finally, our last example, number 14. Chris Riley is a candidate for the city council. His friend Jared is a volunteer for the campaign. Jared is in charge of media publicity. He sends mail about Chris's campaign to the newspapers and to television studios. Jared can prepare 45 envelopes in 20 minutes. Answer the following questions to determine how many minutes it will take Jared to prepare 250 envelopes. Part A. Could this question be answered with a proportional model? So, yes, if Jared works at a constant rate. We need something that we can depend on. He works at a constant rate. If he's starting and stopping and taking breaks, maybe we can't depend on that. So part B, let X represent the time to prepare the envelopes for mailing and Y be the number of envelopes. If a proportionality model is appropriate, give the constant of proportionality. We know how to do that. We take M, that's going to be equal to Y over X. Y is the number of envelopes. He can prepare 45 envelopes in X equal 20 minutes, which means 2.25 envelopes per minute. This is what we would like his constant rate to be. You may have some experience with this if you've ever thought anything related to sports, running a certain amount of laps, say in an hour, or doing any sort of repetition of something in a certain amount of time, gives you this idea of how many things you can do per minute or per hour. In this case, he can prepare 2.25 envelopes per minute. What would be the equation? The number of envelopes, Y, is equal to 2.25 times the number of minutes, X. So now, use this to answer the big question. How many minutes will it take Jared to prepare 250 envelopes? Remember, Y stands for envelopes. So how much time X to prepare 250 envelopes? Notice here, 250 is a value of Y. So this means you're actually plugging in 250 in for Y. You're setting that equal to 2.25x, and you're trying to figure out what is x equal to. You're setting that equal to 2.25x, and you need to figure out the value of x. How would you do this? You have to use opposite operations, which means you need to do the opposite of multiplication. If 2.25 is being multiplied by x, you have to divide by 2.25. And you must do that on both sides. 250 divided by 2.25 is 111.111 minutes. So you can say a little bit more than 111 minutes. Which is the same thing as 1 hour and 51 minutes. So that finishes our lesson on proportionalities, and the word for this lesson is envelope.